Hi there, Dr. Bonfinite. Alright, hi there, Dr. Choi, as well as TAs. Logan, we miss your hair. We're from the Engineering Student Council Corporation, and we're here to show you our newest product.
Alright, so this is our initial device, and as you can see, it's a little mangled, and what we discovered was the photodetector wasn't collecting signals as well as we thought. And in addition, our finger splint can no longer immobilize our finger, so we decided to opt for a more streamlined version, modeled by Will over here.
Okay, so what that is basically a sensor. It has a little photodetector and then also a light. So it's doing the same thing as our setup. It's just a little more compact, streamlined, and stable.
Here's our code.
Alright, so in our code we do set up a while loop for us to continue to acquire the heart rate 5 times what we set times to run, located up here. And this being current run, what our current cycle is. And then we're going to keep acquiring data and a data set of 1,000 points initially, but that can be changed, as well as a window size of 9 just set for our filter. So all that above was just the initialization, and we go into the main part of the code. Now in the main part of the code, we will first acquire all the data using a gather function that we self-created, which communicates with the Arduino device to build a vector of both time and as well as the voltages. Those times being the DT voltage if you take the mean, the DT of each one if you take the mean of it, as well as we can calculate the FS from that, the indices, how many we had, as well as time from that as well. And lastly, we do move on to our filtering function here. Now our filtering function will take in the window size set up above, as well as the acquired voltage from that gather function, and it will filter the data using a nice filtering function inside of it.
Alright, from there we go on to the detrend portion of the code, and the detrend portion is just a way for us to really stabilize our signal. And what we do is we take the filtered voltage, subtract it from the original, and just use our myDetrend function to create a polyfit line using a second ordered polynomial in order to just stabilize things. From there we move on to our Fourier transform, where we have our odd-even function that checks whether our acquired voltage has an odd number or even number of points, and if it is odd, it pads it with zeros. Our convert function is able to just take the fast Fourier transform and then the FFT shift of our data in order to get the frequency versus frequency magnitude plot.
Okay, so from there we calculate the heart rate. So we have some functions we're calling. We're checking to call the heart rate waves, which calls the distance between the peaks, and so it looks at the time between the peaks and dt. So using it, it calculates based on the waveform the time between the peaks, and then we use that to find the average heart rate. And then we have another function where we're calculating the heart rate based on the Fourier transform. So we look at the frequency that we're getting from the Fourier transform, and so we use that to find the average heart rate in the beats per minute. And so there we have 2 different methods to calculate the heart rate within our MATLAB code, which we display both to the user.
And before we end here, Amanda's gonna show us her testimony of our great device.
Prior to this device, I thought I lived a pretty healthy life, but unfortunately, after checking my resting heart rate on this device, I realized it's a little unhealthy and I need to hit the gym more. So Will has kindly also given me his oatmeal, and every day I have a heart-healthy meal.
And that'll be it. Thank you so much for stopping by.